Tinnitus and sleep. A newly recognized link to a debilitating condition for the millions who suffer from the phantom ringing, buzzing, or clicking of tinnitus. The condition is a relentless torment. Now, neuroscientists at the University of Oxford have uncovered a critical connection between tinnitus and a fundamental bodily function: sleep. Their recent research suggests that the two conditions are deeply intertwined in the brain, a relationship that has been overlooked until very recently. The phantom percept and its prevalence tinnitus is considered the world's most common phantom percept, a neurological phenomenon where the brain creates sensory experiences without external stimuli. While many experience these illusions briefly during sleep, roughly 15% of the global population endures the persistent auditory hallucination even when awake. Despite its prevalence, there remains no known cure or definitive cause, despite numerous hypotheses. This matters because tinnitus isn't just an annoyance. It profoundly impacts quality of life, often co-occurring with mental health issues like depression and anxiety. The lack of effective treatment underscores the urgency to understand its underlying mechanisms. Sleep as a suppressor. Ferret studies reveal key insights. Researchers, led by Linus Malinsky at Oxford's Sleep and Circadian Neuroscience Institute, propose that the brain waves generated during deep, non-REM sleep may actively suppress the neural activity driving tinnitus. To test this, the team conducted experiments with ferrets whose auditory systems closely resemble humans. The results were striking. Ferrets exposed to noise-induced tinnitus also exhibited disrupted sleep patterns. Moreover, when these animals managed to enter deep sleep, the hyperactivity in their brains, which fueled the tinnitus, was demonstrably dampened. This suggests that sleep might temporarily mask the condition by engaging the same brain circuits. Our findings indicate that deep sleep may indeed help mitigate tinnitus and could reveal natural brain mechanisms for modulating abnormal activity, says Malinsky. The vicious cycle: tinnitus, sleep, and stress. Further studies, including one from South China University of Technology, confirm this connection in humans. Individuals with tinnitus were found to struggle suppressing brain hyperactivity as they transitioned into sleep. Yet the hyperactivity diminished during deep sleep. This reinforces the idea that sleep is not just a symptom of tinnitus, but a potential therapeutic target. However, the relationship appears bidirectional. Poor sleep can exacerbate tinnitus, while tinnitus itself disrupts sleep, creating a vicious cycle. This is further complicated by stress, a known trigger for tinnitus and a consequence of chronic sleep deprivation. Implications for treatment and future research. The rapid expansion of research in this field, with large-scale studies now exploring the interplay between sleep, environment, and tinnitus, offers hope for new treatments. Malinsky's team is now investigating how sleep affects the development of tinnitus, aiming to break the cycle entirely. Understanding this connection is critical, especially considering tinnitus prevalence in older adults, where it can contribute to social isolation and mental health decline. The insights gained from this research could not only alleviate the suffering of millions, but also deepen our understanding of sleep itself. In conclusion, the emerging link between tinnitus and sleep is no longer theoretical. It's a biologically demonstrable reality. By targeting sleep as a therapeutic avenue, scientists may finally unlock effective treatments for this debilitating condition.